Hello, this is Anthony with Copley Controls. Today we'll be showing how to use the Copley Motion Library, CML, on a Linux environment. So right now I have an ME4. It's been tuned and set up for CAN open mode. So I'm just going to open up the oscilloscope and start a trace. So this trace is waiting for motion. So on my virtual machine, I have an Ubuntu operating system running at the same time. So we download the CML library. We can unzip it here. And we're going to run this make file that's inside of this folder to actually compile the source code. Okay, after we do that, let's run the move example. So there are some examples here. So we'll edit this source code. So for EtherCAT, we're going to comment out the use CAN definition. And for EtherCAT, the CAN node ID is actually going to be a negative number unless you're using the node alias. I'm not, so I'm going to use -1 for position-based addressing on EtherCAT. Inside of the Linux ECAT hardware constructor, we're going to pass the port name. So if we do an ifconfig, we can see the port name here that I'm using. Just copy it and put it in there. And let me actually create an amp settings object. So I changed a setting here, the sync period, to be 2000. I have to do that for my ME3 and ME4 drives because they have a 400 microsecond position loop update rate. So they have to be a multiple of the CAN open update rate, which is 1 millisecond. So the closest value is 2000. So I pass that object in here. That'll initialize the axis. My motor doesn't have an index, so I'm not going to home to an index. I'll just say home none, which just sets the position to 0. And then we'll just make some moves. And that's it. So now I'll go into this example. I run the make file to rebuild the example, or to build the example, and then I'm going to make sure you use the sudo command when you're running these EtherCAT examples, because it's opening up a raw socket in your machine, and in order to do that, to do raw socket programming, you have to be a super user. Okay, so we homed and now we're making moves. The example is running, and we triggered this trace and we saw motion. So this example is successfully commanding motion over EtherCAT on the Linux environment. So it looks like it's set up to do 50 moves. So I'm going to end this now since this is working. I won't wait for all 50 moves, but yeah, this is how you would get up and running on the Linux side of things with an EtherCAT drive. Okay, well now we're going to test a CAN device on a Linux machine. So right now we're connected to an MP3. That's the P there stands for CAN open. So it's a CAN open device, and we're connected to CME over serial. I can see that we're in a CAN mode, so that's great, stepper CAN mode. We're just going to connect to Axis A, same as we did before, this time over CAN. So in the downloads, we've got this Copley CAN driver. We got the Copley CAN driver from our website, downloaded it, unzipped it, and then in here we have the make file. We also have a nice README, so if I go into the README, we're just going to run these commands from a terminal. So first we run the make command from inside the directory. Okay. Great. So just make sure you're using the GCC version that that matches with your driver version. I'm using version 12. Okay. After do that, we'll run this command here, sudo command. Okay, the file already exists because I already installed this driver, but you run that command. Next, we'll do this one, make install. Okay. So the driver, after you do that make install, it'll automatically find any CAN drivers that are any CAN adapters that are attached. So before you do this make install, actually make sure that you have the device connected. You can see there I have it attached. And then these files will be created in this directory. So next is this command. So if we want to have file permissions, we're going to execute this command here. So I'll copy that. Great. And then lastly, if you don't want to have to do this every time you start up your computer, you just add this line to this file here. There's a file called 10 CAN card rules. So you'd go to this directory here. So okay, and you can see there in this file, I already inserted that line there. So you save that, and then every time you start up, you'll have admin privileges, so you don't have to run any of these lines again. Okay, now that the CAN card is installed, I can go ahead and run an example. So we already built the CML library source and header files for EtherCAT and CAN. So I'll just go into an example now. And let's edit this example. So we will revert it back to CAN mode. So we're going to say use CAN, this definition here. We're going to go back to using a positive node ID. And so you know it matches the CAN node address that I'm targeting. CAN 0 is the adapter, Copley CAN hardware. The sync period here, we're not going to set that. We'll just use the default settings. And that's it. It should just work after this. So let me save it. Okay, so let's do an immediate trigger here. So yeah, we can see that we're making moves here, trap moves and S-curve moves over the CAN open network. While this is running, at the same time, I'm going to open up another terminal, and we can see the CAN view software as well. I just downloaded that from our website. So if we go to downloads, just run CAN view. Here we can see all of the frames being sent over the USB to CAN adapter. So this is a great tool for creating message logs for debugging any kind of issues. All right, well, this ends the tutorial. I hope this was helpful, and please reach out to Copley Controls with any questions.